Here we are showing us calibrating the calibration meter, which shows the levels of pH in a solution. And first we are using the buffer of a pH of 7. The buffer works by reacting with an acid solution or a base solution to donate a proton or accept a proton. Here we are using the buffer of a pH of 4, and we are showing us calibrating the calibration meter correctly for both pHs 7 and 4. Here we are showing the buffer of pH 4, which will not be exactly 4, but it's very close at 3.98. pH of 7 is going to be similar to the pH of 4, where it won't be exactly at 7, but very close. We are getting the pH of hydrochloric acid, which is a strong acid because it gives off H plus protons in a solution, which is why the pH is around 0 to 1, because pH is the measure of concentration of hydrogen ions in a solution. Here we are getting the pH of sodium hydroxide, which is a strong base, meaning that it is fully ionic in a solution. Here we are getting the pH of acetic acid, which is a weak acid, meaning it doesn't fully ionize in a solution. We are getting the pH of apple juice, which is actually very acidic. Most people get acid reflux from drinking apple juice because it is so acidic. We are now getting the pH of orange juice, which is also very acidic. This is a table of our exercise 1 solutions with the pH values.
To reiterate, strong acids completely dissociate in water, and when this happens, the strong acid donates its hydrogen ions. From this, equilibrium happens when the formation of hydronium ions balances out the strength of the strong acid. A weak acid does not fully dissociate, and the reaction is reversible. Equilibrium favors the side with the weak acid.
This is a picture of our lab notebook from the acid and bases experiment.
A buffer solution is an aqueous solution consisting of a mixture of a weak acid and its conjugate base, or a mixture of a weak base and its conjugate acid. A buffer solution is resistant to pH change because of the equilibrium between the weak acid and the conjugate base. If a strong acid with hydrogen ions is added, the equilibrium between the weak acid and conjugate base will reverse, making up for the added hydrogen ions. The concentration increases less than expected because of this.